My name is Donovan Brown. I'm a process consultant from Notion Solutions. I'm also a certified professional Scrum Master, certified professional Scrum Developer Trainer. I've been writing software for over 14 years in a variety of languages. You can also follow me on Twitter or follow my blog as well. Today we're going to actually data drive a coded UI test, and this is going to be a little bit different than some of the other data-driven coded UI tests you might have seen. We're actually going to take the calculator application and actually data drive it by clicking any buttons on it that we want after we actually create the recording. So let's go ahead and get started real quick. I'm going to go ahead and create a brand new test. This is all done inside of Visual Studio 2010. I'm going to go ahead and select a coded UI test, and for this demonstration I'm going to go ahead and select all the default values here. You can obviously rename this test anything that you'd like. You could obviously name this test project anything that you would like. I'm going to go ahead and set the defaults here, and we're going to go ahead and get started recording this coded UI test. When you create a coded UI test, you have two options. You can actually bring in an action recording that you might have created using MTM, or you can basically have it use the coded UI test builder, which is the way that we're going to do it here for this demonstration. When I select this option, it's going to minimize Dev Studio, basically giving me my entire desktop as my area for me to record my actions, and it's going to bring up a little coded UI test builder dialog that I will describe to you here in just a moment. So let's go ahead and select the first option and get going on this recording. So as you can see, it has minimized my Dev Studio, and it's also presented me the coded UI test builder. So let's take a quick tour of the buttons we have available to us. We have the record and pause button, which allows us to tell it when to watch the actions that we're actually performing and when not to watch. It will have a little show recorded steps icon. By clicking on this, it will show me all of the steps or the actions it's seen me take so far that it's actually been able to collect and track, of which we can then create a method from if we'd like. We have the crosshairs here. This crosshairs is going to be able to be used to actually highlight any areas or controls on the screen that we're interested in and allow us to be able to interrogate some of the properties. We're going to be using this when we actually start adding validation to our test case to make sure that the addition or the arithmetic is actually performing correctly. And then finally, we have the generate code button. The generate code button will generate a method inside of our test project that encapsulates all of the tasks or the steps that we've collected since the last time we asked it to generate steps for us. So let's go ahead and get started and start the calculator. So what I'm going to do is I'm going to ask it to start watching me, and then as it's watching me, I'm going to go ahead and use the run command to start a calculator. At this point, I've done enough to actually justify creating a method, because I'd like to have a method that I can actually recall that knows how to start the calculator. So at this point, let's go back and let's just tell it to generate code for us. I'm going to name this method start calc, and what it's going to actually do for us, it's actually going to create code that now knows how to perform the steps necessary to start the calculator. Now that we're back here, I can actually restart my recording and continue on with the next steps. And this is something that I forget to do very often, is I forget to re-click the start recording button again, and I'll start clicking around my application, go to generate code, and nothing's been captured because I wasn't actually recording. So make sure after you've generated code, be sure and re-click on this button so that it's watching when I do again. So I'm going to simply click on 5, and this is another great point because I like to be able to click on buttons individually. So let's say click 5, for example. Have to make sure and remember to click on the resume recording button. And now I'm going to click on plus, and let's go ahead and generate code for that as well. So click plus. Now resume again. Let's click on 6 this time. Create a method for that as well. Click 6. And then finally, we're going to click on the equals here. So we're going to resume one more time, click the equals button, and now we actually have something we can validate as well. But before we do that, I want to create a click equals. And now what I want to do is actually start finally using this crosshair. So what I do is I left click on the crosshairs, leave my mouse down and my button down, and I just keep dragging. As you notice, you're going to see certain areas of my screen start to highlight. The one that I'm looking for, however, is this one right here. So when I release my mouse, what ends up happening is that I have a list of all of the different properties on that particular control, and I can actually choose any of these that I want to add a validation or an assertion on. Obviously, I want to assert on the value of 11 being displayed in the display text, so I simply right-click here, say click Add Assertion, And I have several different assertion types that I can choose from. R equals, not equals, contains, does not match, matches, which is regular expression, null, not null. In this example, we simply want R equals, and we basically want to compare the display text to the value of 11. So we're going to say OK for that, and then we actually want to generate code for this assertion as well. So now that I have an assertion set, which you can see by the check marks, I'm going to simply create a new method. It defaults to add assert method. Now I'm going to change this to assert equals, because this is asserting on me clicking the equals button. I'm going to add and generate code. And then one final step that I recommend that you do is always close the application as part of your recording, so you end up with all these calculators sitting on your screen when you're done. So let's record one final time. Let's click on the close button for the application, and then generate code that knows how to close the calculator. Now when we're done here, we simply close the Coded UI Builder, and it'll return us to Dev Studio. Okay, now that we're inside Dev Studio, we can actually see the code that it generated for us. Every time that I asked it to generate code for me, it did just that and generated a method called start calculator. Click 5, click plus, click 6, click equals, assert equals, and then close the calculator. So at this point, I should be able to run this. So what I'm going to do is simply right-click in here, click on Run Test, and I am letting go of the mouse and letting go of the keyboard, so I'm no longer controlling my machine. And let's see if it can actually run this test for us. All this is actually happening automatically by the Coded UI test. I am not actually interacting with my application or my computer. So that's perfect. So now we actually have a Coded UI test that actually knows how to add those numbers. The next step is to actually data drive this using a CSV file. Before we can data drive this, we have to figure out a way that we can actually click whatever buttons that we want. As you can see, it's already shown us has code to click 5 and click 6. But at this point, you pretty much have to be a developer. You have to be able to actually reverse engineer the code that was generated by the Coded UI Builder and determine how we can actually go back in there and click any buttons we want. Let's go ahead and look over here in the Solution Explorer. One thing you're going to notice is what we call a UI map file. This UI map file has actually mapped out the calculator components for us, the ones that we've actually interacted with so far. And it's created two different classes for us. One class, two different files. One of them is the designer files. This is like a hands-off. This might as well be called the forbidden file, because you should not make any modifications to the designer file, because it will be regenerated at different points throughout your code generation. So if you actually need to augment or add your own personal code to a Coded UI test, you want to be making those changes in your UI map file, not the UI map designer file. Okay, so what we're going to do here is we're basically going to have to reverse engineer how they clicked 5 and write our own method that will be able to click whatever button that we want. And the way that I think we're going to be able to do that is I need a method called click that actually takes the value that I want you to click. Okay, and then somehow click that particular button. So let's go ahead and just start reverse engineering this. So what I'm going to do is I'm going to place my cursor inside of the name of the method that I'm interested in learning about, and then I'm going to press the F12 key on my keyboard. What it's done is it's jumped me to the definition of this particular method inside of the code. So as you can see right here very quickly is that there is obviously a class called mouse who has a static method on it called click that knows how to click some button. So at a minimum, I'm going to need this section here. So let me go ahead and copy that, and then let's paste it back into the code that I want to write myself. So I'm going to go ahead and paste this here. The coordinates are optional, so we don't need those, so I'm going to go ahead and take those out. I don't like that name of that variable, so we're going to call ours just button. But now we have to figure out how do we actually declare that button and make sure that it clicks the right button on our calculator. So let's go back to where we were just a moment ago in the designer file, and let's start going back and tracing back where we want to go. So again, I'm interested in this UI item 5 button. So I'm going to highlight it and press F12, which basically shows me that it is a win button. And all we're doing here is we're basically setting this value to a property off of the UI item, which is in the UI calculator window, right? So this UI calculator window has a button in it called the UI5 button. So let's go ahead and click on this. And now what we can see here is we're basically instantiating a win button whose parent is that calculator window we were just talking about. If we go back here, so the parent of this particular item here is basically this UI calculator window. This is the parent, and inside of there we're calling a constructor for a win button and passing in this. So let's go back here and let's go ahead and steal this declaration as well. And what we're going to do in our own code is we're now going to write a instantiate our own win button that we're just going to call button here. and its parent we now know is actually going to be the UI calculator window. Okay, so as you might notice, we have some squiggly lines underneath here. The reason why is because there's not a using statement in this class that actually understands the when button. Really nice feature here is simply right click on here and then go all the way to the top and click on resolve, and it will actually resolve that for us. So now that guy's happy, so that's great. I think we're close, but we're not done quite yet because there's some code here in this search criteria region that's very important. So let's go ahead and expand this region, and as you can see, there's something called a search criteria, and that's how it's actually determining what button is going to be clicked. It's saying I need a button inside of the calculator, and the button that I actually want you to be is the button whose value of their name is equal to 5. So let's go ahead and grab this and take this over to our code as well. So I believe that we're going to place it here. Obviously we're using button, and then what we're going to do is the search criteria needs to be equal to the value that we pass in. Okay, so at this point we're instantiating a button inside the calculator, identifying what button we want, and then we're actually going off and clicking that particular button. Okay, so now that we have that, let's go back and augment our coded UI test to use our method instead of the methods that came out of the box. So what I should be able to do now is actually call my click and pass in the value of 5 and the value of 6. Now if I've done everything okay, this should build, which it does, and it should run the exact same test that we just ran a moment ago. So let's go ahead and run this test case and see what happens and see if I did this all correctly. You can see it bringing up the run command, starting the calculator. It's going to click on 5, and it's also going to click on 6, and it totals 11, so everything's great. So we're halfway there. We now know how to click on the buttons. How do we go in there and change the assert value if the values change? Because if we were to actually click on this here and actually say 6 and 6, the value is obviously equal to 12, not 11, so this test case should fail. So let's go ahead and run this test really quick and see exactly what a failure looks like. So it's going to go start the calculator like normal. It's going to click on 6 instead of 5. Click on 6 again, and now we have a 12, and we obviously have a failure here. And just like when we have unit tests, as you can see, the error message clearly tells us that we expected 11, but we got a 12. But in this case, we actually did expect 12. So how can I augment our test case to make sure that it actually knows that we've actually changed the buttons in which we're clicking on? One other side effect that I want to bring to your attention that we're going to correct here as well is that when the assertion failed, the calculator stayed open. The reason why is because it did not continue to run my test case as soon as that exception fired. What we wanted to be able to do is go ahead and close the calculator anyway, and I will show you how to address that as well. Before we start closing the calculator, I'm going to show you first how to correct this assert situation that we have here. So we're going to go back to our test, and when it created this assert equals method for us, it also created some properties which we can actually manipulate that allow us to change the behavior of that assert method at runtime. So what we're going to do is we're basically going to go in and we're going to find that additional properties. As you can see here, it's one of them that's called assert equals expected values. Inside of this particular item, there's going to be a property called the UI item 11 text display text, and we're going to basically set that value to be 12 instead of 11. At this point, this test should now pass, and now we have all of the plumbing that we need to be able to data drive this, because all the touch points, they basically, the first number, the second number, and the total value can now actually be augmented or changed so we can actually drive it from an Excel spreadsheet or some other data source that we might want. So perfect. We now have a test case that is passing, and all of that values can now be data driven. So the next step is actually to connect a data source to this particular test case. Okay, so now why don't we just create a very simple data source? And what I'm going to do is simply go to New, and let's create a new text file, and we'll just save it as a CSV, which is just commented and limited. So I'm going to need to know what the left-hand side value is going to be, the right-hand side value, and the total. So let's go ahead and put in some values here, and let's do 5 and 5 equals 10. And just for fun, let's go back in and put in an error, which is 5 and 6 equals 12. And then finally, let's put in 10 and 10 equals 20. And see how we go. So let's go ahead and save this. And we're going to save this underneath my test project here. And we'll simply call this data.csv. Now that we have a data source, let's data bind our coded UI test. The easiest way to do that is to go to your test menu, bring up the test view, and then simply highlight the test case that we're interested in. And then down here in the properties window, you're actually going to see a property called the data connection string. Simply click on the ellipsis to bring up a dialog box. We're going to select a CSV. We have to simply browse to that CSV that we just created, which is going to be buried deep in here. Where's my test project? And my CSV. It's going to read that CSV file for us. Make sure you remember this, left-hand side, right-hand side, and total, because we're going to need that once we get back into our particular test case. Let's click on Finish. Now it's asking us here, do we want to actually add that data file or that data source to our project, and do we want to also add it as a deployment item? The reason that this is important is because where your tests are run is not where the code is actually generated or compiled to. So if we don't carry this file along with it where we're actually going to execute our code, obviously we're not going to be able to find our data source. So simply select yes so that it actually takes care of all the heavy lifting for us. Now if we look at our actual test code, you'll see that there's a new attribute here that data binds us to the data source that we've just selected. So now what we need to do is, instead of actually hard coding 6 is here and hard coding the value 12, we need to read that from the data source. The way that we do that is we actually use a property called test context, and off of there's going to be a property called data row. A data row represents every single row inside of the data source one at a time. What we need to do is just use normal ADO.syntax here and just say that we need the left hand side here. And we need that to be a string, so I'm going to go ahead and do a toString on that value. Here we need to do very similar. We need to go ahead and have a test context here, and we need the data row out of here. And after the data row, we're simply going to grab the right hand side and also put that to string. And then finally we need the total. So here we simply replace this string with test context once again, data row once again, and instead we're going to put total and go ahead and make sure that that's going to be represented as a string. At this point, if I run this test case, it's actually going to run through each of the 4 rows in our data source and actually execute the entire program. We're going to see actually a couple problems. We know for a fact that we did bad arithmetic, but there's something very interesting is going to happen on the very last line of this execution of this test. I usually, when I do this demonstration live, I ask people before I run it what's going to break. They obviously get the fact that the arithmetic is wrong, but they don't always pick up on what happens for the very last test. It's very, very interesting actually. The first time I did this demo, I used that data source, and I was shocked when it failed as well, because it didn't dawn on me originally why would my test not work on that very last instance. But it all comes back to that search criteria that we used, right? It knows what button to click on based on the value that we're actually telling it to click. We're actually telling it to click 5, or we're telling it to click 6, and on the last instance we put the left hand side is 10 and the right hand side is 10. So it's actually looking for a button named 10. There is no button named 10. There's a button with a 1 on it and a button with a 0 on it, but no button with a 10 on it. And as I mentioned earlier, we have now 2 calculators still running. One of them where the arithmetic was wrong, because that should have been 12, and one where it could not find the 10 button. And the way that I can explain that to you is if we come here to our test results, right-click on it, and say View the Test Result Details, we can actually see what's going on for each one of the individual test cases or runs for the data row. We can clearly see here that it expected a 12, but it actually got 11. And here we can actually see that it was having a whole lot of trouble trying to execute because it was not able to find the actual controls that it was supposed to. If you double click on these, you can get a little bit more information. And it's failing because it was not able to find a button with the name 10. So let's go back. Before we fix these two, what I want to do is show us how we can actually stop the calculator from staying open on failure. There's a couple things that we need to do to actually correct that. So let's correct that first, because I'd obviously need tests to fail to prove that we've actually solved that particular problem. So first thing we need to do is we need to make sure that this tool actually continues to run on error. So the first thing that I want to do is I want to use a play settings property or playback property, and inside of here there's playback settings, and then there's a property called continue on error, and it defaults to false, so we want to set that to true. Unfortunately, that's not enough. There's a couple other things that we're going to have to do. If you look down and you expand this region called additional test attributes, One of those additional test attributes is what we call test cleanup. There's also test initialize. These are methods that are going to get fired before and after each of your actual executions of your test. So if I wanted to, I could move the start calculator into initialize, and more importantly, I can actually take the close calculator, which is far more important, and make sure that I move it out of the test and put it inside of my cleanup. By telling it I want you to continue even on an error, this cleanup code will continue to be run. It doesn't mean that it's going to continue running my code past the assertion, only that it will make sure that it runs the cleanup and the initialize. That's where we're forced to remove the close from here. Moving the calculator start into here, it's optional, it's not really necessary, it really doesn't affect us much, but just as a good practice and get measured and prove that this is actually going to work, we're going to move the start calculator down into initialize, put the test in the test cleanup, we're going to put the close, and now if we run this, even with the erroneous data sources, we should have no calculators still open at the end of our test run, although 2 of those tests are still going to fail. So what we're going to do then is we're going to go back in, correct our data source, and also correct our tests so that it understands how to find do arithmetic on numbers that it can't find buttons for, because we really need to click a 1 and a 0, not just click on or search for the number 10 as a button. So I'll go back in and we're going to fix our data source to get the correction, so you can see how you can fix the data source after your tests have actually been created, and also correct our tests so that it can actually basically do arithmetic on any length number that we want to pass to it. Again, as you may have noticed down in my status bar, this calculator in a moment is actually going to disappear. And so as it's trying to time out, it's trying its best to find a button with the name 10. It's not going to be able to find that, so it's going to go ahead and continue executing this particular test case for me and eventually close our calculator, bringing us back into our IDE with no calculators running. And then we'll have an opportunity to go back in there and actually correct it. So as you can see, my taskbar is completely empty. There are no calculators remaining running, and we still had the same 2 errors before. So to fix the first error, what we obviously need to do is come into our Solution Explorer, find our data source, and correct our problem here, which is this should still be an 11. So our data source is fixed. That fixes our first failure. Our second failure is a little bit more fun to fix. We actually have to go into our code. Now, instead of actually clicking the left-hand side, I need to be able to click each individual character of the left-hand and right-hand side. So what I can do very simply is simply put in a for each char C in the left-hand side, I need to click that character. And then I basically need to rinse and repeat this change here for the right hand side as well. So we'll simply copy this code here and put the right hand side here instead. At this point, I think our test is golden. So let's go ahead and run this test again, and we should have 4 iterations run. 4 iterations also succeed in generating exactly what we want. So let's just go ahead and watch this one last time. And if this works, then feel free to send any questions you have about this webcast to notionsolutions.com, and we can get you any additional information on this particular web recording. Or if you'd like to see a different one, just let us know. We'll be more than happy to go back in and record any webcast that you can that you're interested in seeing. So let's see, 1 0 plus 1 0. Everything's perfect. So I hope you enjoyed that quick look at it, driving a coded UI test and how to reverse engineer the code that's been generated and how to make sure that your playback continues on error. Take care. If you want to know more about us, you can obviously go to our website at notionsolutions.com. But before I let you go, I'd like to tell you about a couple of the other offerings that we actually have at Notion Solutions. We do on-site and public training classes. Like I said before, I'm a certified professional Scrum developer trainer, so we actually have courses on certifying you as a Scrum developer. We also have a lot of targeted training on particular areas of ways of using Dev Studio. One of them that I've taught several times, actually literally all over the world, is the tester training, which is very popular, which gives you a chance to play with a lot of the testing tools that I just showed you, and we go much further than that with web testing. We also do load testing. We show you how to use the coded UI test, manual test inside of Microsoft Test Manager. A lot of the great new offerings from Microsoft are actually taught in that particular class. So the tester training class is a very popular one that we've been doing a lot of. But
All of our training content is a lot of fun because it's really hands-on. It's not just listening to someone lecture. We actually bring in our own hardware and allow you to actually kick the tires of the tools that we're demonstrating for you. Not only do we do training, but we also do quick starts. Quick starts are where we have a Notion consultant come into your environment and actually get you going with TFS in a very rapid pace. So we can get your team upgraded to a new version of Team Foundation Server, get you Team Foundation Server installed, and get everyone connected to Team Foundation Server and actually using the tools in a very high efficient way. So if you guys are interested in any of the training or some of the quick starts, obviously you can visit our website, but you can also have our contact information here as well, so that we can come on site and help you guys use TFS to its fullest potential. So I hope you enjoyed the webcast, and if you have any comments or suggestions, please forward those along on our website. Take care.